this video, we'll see how to square a circle using the Quadratrix. Start with a circle of radius r, and our goal is to use the Quadratrix to construct a square that has the same area as the circle. Namely, we want a square with area equal to pi r squared. Now, looking at the Quadratrix, we assume that the curve is drawn inside a square where the lengths of the side of the square are 1. If that's the case, then the segment along the bottom between the corner and the curve has length 2 over pi. Now begin by constructing a rectangle of area 2r. We do that by drawing one side of length 2 and then the other side of length r. Now, how do we find length 2? Well, if the square that the Quadratrix is in has sides of length 1, you're just going to double that length. How do we find r? Well, r is just the radius of the circle. Now we're going to use the application of area construction, where we're going to construct a rectangle of height 2 over pi. 2 over pi is the length that we got from the Quadratrix. Now remember how the application of area construction works. If your original rectangle has area 2r, then the area of the newly constructed rectangle has the same area, 2r. Now we're going to analyze this rectangle at the bottom that we just constructed. So here it is. The height of that rectangle was 2 over pi. We know that the total area of that rectangle is 2 times r, because that's how application of area works. Now, using algebra, if the length times the width of that rectangle is 2 times r, that means x times 2 over pi is 2 times r. We solve for x to get x is equal to pi r. Now, by the way, I just wanted to make a quick little comment. What if instead of trying to square the circle, meaning draw a square with the same area, what if you were trying to rectify the circle, meaning draw a segment that has the same length as the circumference of the circle? Well, notice we just constructed a segment x of length pi r. If you double it, you get 2 pi r, which is the circumference of the circle. Okay, let's get back to our squaring the circle problem. So now we have a segment that we called x that had length pi times r. Now, before we construct a square of area equal to the area of the circle, let's first construct a rectangle whose area is the same as the area of the circle. So let's use the pi times r as one of the dimensions of your rectangle. But what must the other one be? Remember, the total area of this rectangle that you're constructing is pi r squared. That means that the other dimension of the rectangle must be r. So in other words, if this area is pi r squared, this area is pi r squared, but one side is pi r. What is this other side, y? Well, y has to be r. And then the total area of the rectangle is pi r squared. Finally, you use the geometric mean construction where we have one side of the rectangle plus the other side of the rectangle, and then the geometric mean of those two numbers is going to be the length of the side of the square that has the same area as the circle.